rectangle there. So this this approximate the area of the curve with rectangles. You're building these rectangles, 4 of them here, and they all have the same width. Okay, now that width is what's called delta x, which is b minus a over n. That's 2 minus 2 over 4. The 4 comes from right there. Okay, and that's how I got this width of 1 for each. Okay.
Okay.
So then, like in terms of the height of the rectangle, it comes from evaluating the function. So the area of that first rectangle there is f of 1, which is e to the 1 plus 7, okay, times the width. Okay, so the rectangle 1 there, we'll call it as e to the 1 plus 7 times 1. Okay, and then I'm sorry, that's not correct. It's negative. We're doing it at -2. Why am I doing that? So you're doing it at -2. So it's e to the -2 plus 7. And then from here, you get some sort of a number there, but then you multiply it times the width of the rectangle, which is 1. And then you do the same thing at -1. The reason -1's right there, you get the height. The height comes from the curve, e to the -1 plus 7. The area of the rectangle is e to the 1 plus 7 times 1, base times height or length times width. And then so on here for this. So e to the 0 plus 7, e to the 0 plus 7 times 1. And then for the last one at f of 1, it's e to the 1 plus 7. You're just evaluating that function, and then you're multiplying by the width. So the answer to part A is putting all this into a calculator and getting out the result. Now you might ask, well, why not do it at 2? Because if you go to 2, 2 goes a little bit higher. The left endpoints start from the left. That's why I use the left values to do that. So in full disclosure, you never have to do this ever again, and you can just find a calculator that does this for you, which is what I'm about to do, because it does take a long time to actually do this. Plus, it's just around 2 decimal places. So they make a calculator for left, right, and then the midpoints. Mm-hmm. So I'm just going to go find that one. I'll show you where that is here. I'll just switch to that screen in a moment here. Mm-hmm. All right, so let me menu share this screen. All right, so this calculator, it's called a Riemann left endpoint rule calculator, and got all the adds going, of course. So you just enter your function, e to the x plus 7, and then that's from -2 to 2, and then you enter in your number of rectangles, which is 4, and you calculate. Now there's a ton of these out there on the web. I just happen to like this one because it's got all the values. Or it's gonna give us all of them that we want. So it says 2 decimal places. So let me go back and snip in all the answers so that I can write the result in and then share that screen. But it takes it's doing the calculations that you normally have to do by hand. But again, students are given a calculator here, so it's really no different than that. So the first one is 32.22. So now I've got to go to the right endpoint rule. Unfortunately, this one you have to re-enter the function. There's other ones where you don't have to do this, but this is the one I just go to when I need to do this stuff. And so this one is 39.48. And then the last one we need is midpoint. Midpoint here. So same thing here, e to the x. I think this is the only problem with this one. So it's why I'm doing it this way rather than spending a lot of effort on it. So this one is 34.96. All right, let me go back to the other screen. Okay, so I've got these numbers entered in. For part C, it's just the average of A and B. So let me grab my calculator here and take the average of those two numbers. So we're finding the area under the curve, and this is a way to approximate it. This is it's a really good approach, especially when you make the rectangles really small. But that's it's a very calculus thing. So new software uses these rectangles when they're performing integration steps, and they just make the rectangles really tiny widthwise, so that it basically fits the curve. That is it. That is it for number one.
Okay.
Number two will make more sense here.
Awesome, I got those.
Okay, so number two, letter A. So number two, letter A, it's asking to find the integral from 0 to 12 f of x dx. What this means is to find the area under the curve from 0 to 12.
Okay.
So it's basically like, well, what's the area of this triangle? So you actually don't even need calculus. It's 1/2 base times height. The base is 12, and the height is 1, 2, 3, 4, 5, 6. So the answer is 36 for part A.
Okay.
And that's conceptually what we're doing in the last problem, but like sometimes you can just do it with formulas because you recognize the shape.
Totally.
Okay, now for part B, let's see what part B is. So part B, again, you're doing it from 0 to 12. F of x dx. Your f of x is this function, and here is 11, and then there is 12. So you actually have two triangles. So that first one is, again, it's 1/2 base times height. Your base is 11, and your height is 13, 12, 11, like that, which is 121. And then that other triangle, same formula, 1/2 your base times your height. Your base is 1 and your height is 1. So that's 0.5. So it looks like when you add these together, you get 121.5.
Sorry, is it 121?
Oh,
is it
yeah,
half of 121?
Yeah.
Okay.
That's not right. It does work out nicely. So half of 121 is 60.5 plus 0.5 is 61. You're welcome to check that in a calculator needed. So that you might think, okay, well that's not too bad. If the rest of the quiz is, the rest of this is like that, it's like, okay, well I can do that. But it does get a little bit harder because they don't always give you the graph. Okay.
Okay.
And that's what's going on here in the next one. They want you to do this thing right here. You're like, what is that? So if we go to let me go to back to that other screen here, if I can find it. And we'll go to Desmos this time, graphing calculator. And if you graph the what's inside, it's the square root of 100 minus x squared. And you zoom out a little bit, you're like, oh, that's a half circle, right? But we only want it from minus 10 to 0. So now it's a quarter circle. So the area under the curve here, and I'll grab a snip of this. Snip this in here to the other page. All right, let me go back to it. The area under the curve is this quarter circle. And so the area of a circle is pi r squared, but you only have a quarter of it. So you just need the radius, and the radius in your problem is 10. So you have a radius of 10, 1/4 pi, 10 squared, and that becomes 25 pi. So you're using geometry in calculus to figure out these
yeah, it's definitely coming back to haunt me.
Yes,
but all familiar, so that's good.
Yeah, the believe it or not, students are actually very confused at this point, and I think it's because they don't know their functions real well, which is what I'm hearing from you. Is like, which is fine. I mean, it's not a knock on you. It's just if you know the geometric shape of this, it's like, oh, you can just use a formula that's very familiar. Or supposed to be. Okay, so the next problem here, it says to do this integral area under the curve of 1 plus x from 2 to 4. So geometrically, the graph of 1 plus x looks like this, and you're going from 2 to 4. So you really are you're just doing this part right here. This is the graph of y equals 1 plus x, but you just want it from 2 to 4. So you're just finding this area. So this is a trapezoid. Area of a trapezoid is 1/2 base 1 plus base 2 times the height. Now it's maybe not the trapezoid you're used to maybe the bases being on top, but it's still trapezoid. So your bases end up actually being the heights. So this height is 3 on the left, this height is 5 on the right. So it's 1/2 3 plus 5 times the height is now like the width, 4 minus 2 or 2. Maybe we'll do that in case you look at this later, 4 minus 2. And then that's 1/2 of 8. So that's 4 times 2 is 16.
Okay. Fun.
Nope, I'm sorry. That's not the right answer.
Okay.
It's so 1/2 of 8 is 4 times 2 is 8.
Oh, totally.
Yes.
Dang, I even was like, yeah, that makes sense in my head. Yeah. Okay.
And the other thing you can do, which I mean, I'll just point this out really briefly, is you can actually like, you could break it up into other shapes, or you can just count squares. 1, 2, 3, 4, 5, 6, 7, and then if you bring this triangle on the left up to the one on the right, it ends up being 8.
Oh, that's a fun way of looking at it.
Yeah, but like all good things, they come to an end.
Right, and it's probably now.
It's about now. So this problem requires you to do a slightly different approach here. So you could graph the quadratic, but the quadratic is not straight lines. It's a curved line. You'd like a nice smooth shape like that when you draw it. You don't draw it like that. So this one requires you to actually use calculus. All right. Now last week we covered the power rule. So the integral of c x to the n dx, where c is a constant, is c x n plus 1 over n plus 1. Okay, so the power rule says you add the exponent. So it becomes 2 plus 1, or 3 over 3. And then there's an x to the 1 here, so that becomes 8x squared. You're adding 1 over 2. For a constant, the integral of a constant dx is cx. So that 5 becomes 5x. We did that, and then we wrote plus c. So now for this week, what's different is you use the limits of integration. Okay. Which means you're going to evaluate this thing at the top and the bottom. So it's what this means is top minus bottom. You evaluate at the top, so you put that 2 in for x. And I'm gonna this is really 4. 8 over 2 is really 4 squared plus 5 times 2 minus, and then the bottom. So the bottom's all in parentheses. So it's 7 over 3, 0 cubed, minus 4, 0 squared, plus 5 times 0. And 0 times anything is 0. So everything on the right becomes 0. That does often happen in these problems. Okay. But on the left here, you got non-zero. So you gotta be comfortable manipulating this. So 2 cubed is 8. So you get 56 over 3. And then 4 times 4 is 16. But because it's over 3, we'll go 48 over 3. And then 10 is really 30 over 3.
Wait, is it over 3? Because you already simplified the 8x.
But I'm doing the first one. and so 2 cubed is 8. 8 times 7 is 56 over the 3. The first one here is x squared. X squared becomes x cubed over 3. You add one to the, yeah.
I follow that. I'm not following the 48 over 3. I don't.
So 2 squared is 4. 4 times 4 is 16. And then I'm just converting it to the.
Oh, it's your common denominator. Okay.
Yeah.
I gotcha. Sorry.
That's okay. It's good to ask. So this becomes it looks like it becomes 48 over 3. Maybe. I don't know. Let me think about that. 38 over 3. So I'm also going to go check this in another calculator because, in students would do this. You might not be given a calculator in this one, but in your class, you're given it for everything. So we could do that. But let me just quickly check that this is actually what it's supposed to be. And that way I can confirm it here. All right, integral 7x squared minus 8x plus 5. Yeah, that's correct.
Okay.
All right, so next question. Next question is, all right. Oh, and these are the same. There's no differences in your what you're seeing on your side. The problem
correct.
Numbers. Okay, very good. Okay, so we did this last week, or I guess we did use substitutions last week. Yeah. The you like, this probably looks really complicated. You have to, if it was not with, it didn't have the numbers, it would be like last week where you'd make a u substitution, and your u is natural log of x, and your du is 1 over x dx, and then you solve for dx. Dx is du times x, and then you substitute back in. So it's 12 u to the 5th, because u is natural log of x, over x. Dx is du times x, and then the x's cancel. We did that last week. Now, what's different about this week is we're really supposed to, when you make a u substitution, you're supposed to change the bounds. So u of 1, you actually put 1 into your u. So that's natural log of 1, which is 0. U of 5 is natural log of 5. So your new bounds of your integration, 1 goes to 0 and 5 goes to natural log of 5 for this new. You don't have to do this, but it's generally preferred when you get these problems, because they usually work out nicer. So we're back to the integral 0 natural log of 5, 12 u to the 5th du. Okay, and from here it's power rule again. So it's 12 u to the 6 over 6, which you're evaluating from 0 to natural log of 5. So eventually you start canceling your denominators in this problem. So you always do top minus bottom. So then it's 2 natural log of 5 to the power of 6 minus 2 times 0 to the 6th, and that's just 0. So this is your final answer. Just be careful entering it. I think Pearson likes to throw in a parenthesis there, so just maybe something like that.
So even though in the original problem there's a denominator of x?
Yes. See how it canceled?
Okay.
So when you do the u substitution, it's supposed to cancel.
Okay.
So they call it, it's called a change of variable. We do this in other functions in life, where we make a change, and yeah, everything from the old is supposed to be gone.
Okay. Sorry, you mind scrolling down?
Oh yeah, sorry.
No, it's okay. Okay.
All right, so we're looking at another problem here. Let me just frame this correctly. I'm going to snip in the graph. All right, sorry this is taking so long. It didn't snip in well.
No, you're
Okay.
good.
So when you read this question, if you do, I know Matt is reading an interesting Facebook thing on whether some teachers seem to think students actually read the textbooks, which I mean, I didn't read them and I like this
Right.
stuff. I mean, some do, but it's just like, come on. Okay,
Yeah.
it says to use the definite integral to find the area between the x-axis and f of x over the indicated interval. This is the most important. It says check first to see if the graph crosses the x-axis. You're like, oh, yeah, it does. Now, why would you need to check? And the reason is that areas above the x-axis, they're considered positive,
Mm.
and areas below are considered negative.
Makes sense.
Okay, that's pretty reasonable. Okay,
Mm-hmm.
so if you just went to a calculator and you just integrated this, it will say, oh, that's positive, and that's, let me scroll down here, and that's negative. Okay. Now, if the way we read this, though, it says use the definite integral to find the area between the x-axis and f of x over the indicated intervals. So the way I read this, which I mean, it would have been nice to do a homework problem to compare this to, is like the way I interpret this is they're both positive. Like I read this as they want the total area.
Oh.
And I'm fairly confident of that, but yeah, I'm not entirely sure. So if we were to graph the absolute value of this function, like, why would you do that? Well, the absolute value
needs to be positive.
Yeah, exactly. So let me show you that here. So now all the areas are positive.
Mm-hmm.
So if you integrate from 0 to 5, absolute value 8 minus 2x squared dx, that should give you your answer. Now, if we were in a traditional classroom, you wouldn't do this. You would go back to the previous problem, previous way of looking at it. You would integrate from 0 to 2, 8 minus 2x squared dx. That'll give you that positive one. But then you subtract the area from 2 to 5, 8 minus 2x squared dx. They both give you the same answer, but if you're using technology, which students do, they use technology, they use a calculator or they go to a web thing, you do this one on the bottom.
Okay.
Okay, so I'm gonna do that for you off to the side here.
Okay.
I didn't like that. So this ends up being 194 divided by 3.
Okay. Awesome.
All right, give me just a moment here to check something. All right. I think that is correct. You've noticed in the last few weeks I gotta check because like I really sometimes don't know.
Oh no, you're totally fine.
Yeah. So we're in, keeping with just some time here. I'm gonna do more of these using a calculator. So this is the same problem, type of problem. You've got it definitely crosses the x-axis. Okay. So which means you always switch to an absolute value. So this integral means area under the curve of your function, and then from left, which is -5, to right. So like you don't say, squiggly line, -5 below, 3 above. You say the integral or the area under the curve from -5 to 3 of the function absolute value 4x cubed dx. And
Okay.
you can go right to your calculator to get that answer as well, which I'm not showing you, but it does exist on a TI 8083. It's kind of like other things, like when you do something at work, you don't get out pencil and paper and add it up. Hopefully you go to a Excel, or you make some pivot tables, or you do something else besides that. So that is I believe that's it. Yeah. 3. Okay. All right. Go back to that. Okay, so another question, very much like the one we just did. It says check first to see if the graph crosses the x-axis in the given interval. So just the workaround, maybe, I mean, I don't know if you care or not, but I just want to say this. It's the workaround from a teaching perspective is that like you can ask a student to set it up, but not actually do it. And that's like what you really want to take away from this. Like, okay, and you already understood. It's like there's a positive part and there's a negative part, and you can break it up. And so if there were many crossings, you just break it up a bunch of times. And so if you were writing a program or something to do this, you would look for the crossings, and then you would do the ones above positive and below is negative, and it would all work out nicely. Because from here, we're literally just going to do the same thing we did in the last problem, which is the integral, the area under the curve, absolute value 2e to the x -4 from -2 to 3. Notice it says you're rounding to 3 decimal places. That means for sure we are going to a calculator. We are never doing this by hand ever.
Okay.
And like things that your car does, phone, get on an airplane, they are not doing it by hand. They are using software to integrate
Totally.
things. And so it's not pretend like got to. Anyway, -2 to 3. Very good. All right, so this ends up being 33.987. 33.987.
987. Okay.
I really hope this works out, because the next one is a little bit clearer. It says to find the total area of the shaded region.
Right.
So I'm a little like, I hope that what we just did is right. So this one is for sure like we just did. It's the integral of the absolute value x squared minus 2x from -2, -1012, -2 to 2 dx. And it does take care of that for us. I feel like I should check those previous problems one more time. Let me do that after we look. So going to the calculator again. X squared minus 2x from -2 to 2. So being 8.
Okay.
All right, let me just look at these problems one more time, just to make sure. I'm gonna see if I can find a reference.
Mhm.
Okay, I guess I'm gonna be comfortable with it.
Okay.
So, all right, let's look at the next one here.
Are we on 11, I think?
Let me, yeah.
Oh, yeah.
Yes, yeah. And okay, so there's a function again. They tell you it's census in a particular area. They're trying to give you an application of this.
Yeah, right.
right. I mean, like we just wait every 10 years and we're like, all right, well, there's a new census and we know a few different electoral ballots will be available in different places, and I don't know what else. But for us, like all we care about is we're finding the integral over the interval 0 to 9. So you're literally just integrating 40.4 plus 2.1x minus 0.783 x squared dx from 0 to 9. Okay. Now, so I'll go grab a calculator. Then we're going to interpret the result here, and it's probably going to be 258, just looking at the answers, but we'll do that. And it says then part B is find the number of people alive in 2010 that were born in the 50s. That is those in the range of 4 to 5 decades. So that one we're integrating from 4 to 5 of the same function, 40.4 plus 2.1x minus 0.783 x squared dx.
Okay.
So the most difficult part here is just entering it into the calculator correctly, making sure there's no little mistakes. You should do absolute value, but I believe this one's always positive, so you don't have to worry about that.
Okay. Yeah, that makes sense.
But I just do it as
Okay.
a habit here. It's like you just run spell check, even if you think you got it all right. Yeah. All right, so we think this is 258. Oh, that's interesting. 40.4 plus 2.9x minus 0.783x squared. Okay, yeah. So this one is 258.
Okay.
Which we kind of expect because you see the answer 258 in all of them.
Right.
So this is the total number of something. Aged is age distribution. Total number of people in this, it looks like it's C.
That's also what I was thinking.
Okay.
I mean, that doesn't mean much, but
no, it's an interpret. I mean,
yeah.
there's no more math. It's just do you which even sounds reasonable. All right, so then from 4 to 5 is 34 million.
Okay.
there's some good TED Talks on, you know, the population in this country and how it's in decline, and you know there's you know lots of interesting, because there's the growth, and then there's the, I don't know, it's negative, but it's the dying population, and it's kind of interesting.
I bet.
To just see what's going out there. But that's it for that one. Not much more to say on that. Okay, so up to 12. Oh, good. We're doing fine. It was going a little faster than I wanted to, but this is good. We're still going to be able to finish here. Okay, find the area between the curves. So what you're supposed to do is go out and graph them and figure out which is on top, y equals x, and x squared minus 2, and which is on the bottom. So I'll do that here. I'll go graph them, but you'll find the answers, it doesn't matter, because you can switch. You can just use absolute value to figure it out, or if you get a negative answer, you would just switch that. But we're going from -5 to 1. So I'm going to grab a graph here, and so we can visualize this. Mm-hmm. So a lot of students really struggle with this part of the course, because they're like, I forgot how to graph, and you know, it's like, yeah, that's why you learned it. But I get it. The graph, though, is so useful, just so useful to have a picture. You know, I'm working with a 6th grade student, and you know, this teacher's like, hey, you got to make a picture, and like, you know, I can't tell him yet, like you're going to take calculus one day, and this is why you need to be able to draw a picture, so you can do this. But you have to find the 2 separate regions, right? Here you got region 1 and region 2. So what you could do is break it up into 2 integrals like we've been doing, but instead you can also just do the absolute value of the functions, the difference in the functions. So it's top minus bottom in terms of the functions. So I'll just choose that x squared minus 2 and subtract the x. And you're going from -5 to 1. Okay. So just go to our calculator again and get a number here out. -5 to 1. X squared minus 2 minus x. Okay, so this becomes 146/3. So you're noticing more kind of non-friendly answers as we move into this part of the course. Okay. All right. So for the next problem, they don't give you the bounds. They don't. They just say find the area between the curves. So as a student, what you're supposed to do is you're supposed to set them equal to each other and solve for x. But we're going to go get a graph of this, because it'll show you where they intersect and visualize the region between them. So let me do that here. All right, so let me zoom out a little bit. Just change this window. All right, that'll do nicely. Okay, so here is a picture of this. Let me scale it a little better. Okay. So for your problem here, you're looking at, you want the area between the curves, which is this area right here. And so that's the integral symbol. The integral symbol says area between, okay? And it's from left to right. So it's the x value on the left and the x value on the right. So it's that -8 to 5. Okay. And then it's always top minus bottom, top minus bottom. So your top function is the line, 10 minus 3x. And then you subtract the bottom, x squared minus 30. Okay, but if you didn't want to do that, or if you could just do absolute value, but this is correct as is. So you subtract the top minus the bottom, and then hopefully, hopefully just enter in the calculator correctly and get get a number out for the area. 10 minus 3x minus x squared minus 30. And we're doing that from minus 8 to 5, minus 8 to 5. And so again, not a great answer, 2197 over 6.
Okay. All right.
Okay, so the last one here. Last one here is, again, find an area between the curves. So that's the integral. Now they give you the x bounds, so that's nice. Just use those, top minus bottom, or I'm sorry, the left to the right. The left is on the bottom. And then we don't know the order. Like, we could figure it out, but you can just go absolute value, e to the x minus 1 minus e to the x. So it does say below here, which I didn't snip in, it's like your answer in terms of E. So you want to be sure to use a calculator where it actually does it exactly. It doesn't just make an approximation, but most of them do now. I mean, let's go from minus 6 to 1, e to the x minus 1 minus. Oh my goodness. Huh. So I don't like this answer. So it's oh, I'm sorry, it did simplify. 3 plus 2 over e to the 6th plus 2 times e plus the natural log of 4. Well, that doesn't seem right either. Let me go up to the side here and do this one by hand, but let me graph it first. Oh, because of the intersection point. That's why. Yeah. Okay. Well, I can't believe they gave this to you. Yeah. So this one intersects at it intersects at minus 1/2 natural log of 2, something like that, or natural log of 2, and that's why this ln is in there. So yeah, this is okay. Just be careful entering that in.
2 over e to the 6 plus 2e plus natural log 4. Yep. All right.
Okay. Will you submit that and let me know how that goes here?
Yeah, so